Hello to Dr. Nina Kraus and to our audience of sound enthusiasts. My name is Elizabeth Krasnoff, and I just want to say this is my dream interview. I have a passion for researching the auditory brain, specifically the ability of sound and binaural beats to affect the human nervous system and our states of consciousness. I was born half deaf, and I think that this has influenced my life greatly. I've spent my whole life studying sound, singing, making music, healing with music, researching sound and music. I started my own company, Sound Medicine, in 2015 as a way to help heal with music and sound, and really have been involved in every possible inquiry on the topic, all the way to consciousness, to states of consciousness. So, of course, you can imagine that I was thrilled to read this book, Of Sound Mind, by Dr. Nina Kraus. And as soon as I read it, I said, well, I hope I can get an interview and talk to her about this incredible piece of research and organization of the field. Nina is really at the forefront of her field in auditory brain research. She has a lab, her own lab, BrainVolts, which you can access at brainvolts.northwestern.edu to see the dozens of experiments over decades that she has conducted in the field of hearing. She has many focuses to her work, several of which are particularly interesting to me, especially her ability to take her experiments and understand how to help children who have grown up in impoverished environments. Believe it or not, there's a connection between that and hearing and the sound brain. So we're going to learn about that today. And of course, we're also going to ask about binaural beats. I am going to ask her to break down some of her categories for you. One of the things that was most impressive to me in this book is that she takes this vast thing, the auditory hearing brain, and she puts it into neat categories that we can understand. So we're going to start by talking about some of those categories and some of the sound ingredients, which will be a way into understanding her work. So Nina, you write that you can summarize your career in the sentence, "The sounds of our life shapes our brains." Can you tell us a little more about that and really the inspiration for writing this book, Of Sound Mind?
Oh, well, I love sound and the brain that makes sense of it. I'm a biologist, so that's my perspective. And if you go to our website, um, you will see on our homepage that we research music, rhythm, aging, concussion, language, bilingualism, reading. You might wonder, what are they even doing at BrainVolts? And it's all under the umbrella of sound and the brain, which of course includes our body our, as well, our heart and our lungs and our guts. This is a whole system. Um, and I realized, well, I wanted to put this information because it really does hold together. I wanted to put it all in one place because, I speak to people who are interested in autism or dyslexia or music, and, they have their particular perspective, but in fact, there's a holistic perspective. There's so many different ways that sound interfaces with our personal lives. And I wanted to put this information together in a way that would make sense as a whole and that people would get something out of it, no matter how much or how little they know about the topic. You already talked about the that it's accessible. There's something just very, very remarkable about sound, which you and I are experiencing right now. There is what Ian McGilchrist calls betweenness, this reverberation, this back and forth that happens when we are communicating through sound, because sound is alive. And you and I mean, we have an idea about the topics we want to talk about, but we don't have a script. There is this back and forth, this forth and back and forth, which enables us to connect. And I think one of the biggest messages in the biggest theme in my book is that sound connects us. Sound connects us to each other, it connects us to our environment, and it's this very important force to be honored.
The expression came to my mind as you were talking just there, the improvised life. All you talk about in your book.
Yeah, we are everyday improvisers
Mm-hmm.
when we speak.
Mm-hmm. Mm-hmm.
And that's incredible.
Yeah.
And it's so present, it's so alive, and it's so reverberative.
Why do you think, you talk about this in your book, that sight and smell are designed more simply and hearing is a far more complex operation?
I wouldn't say simply, I would just say differently.
Mm-hmm.
And, we have different evolutionary origins. Sound evolved from, it's a very, very ancient sense that evolved from our positional sense. We know that our balance and our hearing organs are kind of encased in some of the same structures, and they have some of the same properties in terms of hair cells that move with vibration, whether the vibration is through the bone, or it starts. We originally began as aquatic creatures, and so the vibration was the vibration of the water, and then as we became land animals, there's still way more water animals than land animals, by the way. The we had to be able to now hear the vibration and the movement of air molecules instead of the vibration of the fluids. And the air molecules,
Mm.
and they have to eventually go into our organ of hearing. One of the ways that we hear is through our cochlea, which is our inner ear, which looks like a snail, and the sound vibrations have to vibrate, have to move those hair cells that are encased in fluid. One of the things that happened as we moved from sea to land is that you call it's a match. The technical term is impedance. Is that there's a poor impedance match between the air movement of the vibrating air molecules and the vibrating fluid in which the cochlea sits. And so that's where we developed a middle ear, which actually amplifies. It's a way of amplifying the frequencies that are especially important for humans. And that's something that evolved. But I think more fundamentally, whether you are a land or a sea animal, vibration will cue you as to very basic survival needs. So this sound that I hear, is it going to eat me? Can I eat it? Can I mate with it? And also you have to remember, oh, I heard that sound before, and that's bad news. I'm out of here. Um, so our information that we get through vibration is absolutely fundamental to survival, and it has been so since the beginning of organisms.
So I just want to jump in here for a second and ask you to break something down for the audience. The auditory brain visits many regions in the brain as it's working, and you have defined those 4 major regions as reward, the reward center, the cognitive center, the sensory brain, and the motor brain. So if you could talk about that a little and explain the significance of engaging all 4 of those sections of the brain.
Thank you. The hearing brain is vast. And you're right, most people just think, oh, the ear. No, the hearing brain engages our the formal way of saying it is our cognitive, sensory, motor, and reward networks. So let's unpack this. Our hearing brain engages cognitive, what we know, what we remember, what we pay attention to. So our hearing brain very much engages. It's a back and forth, by the way, and there are. I like to think of the brain more as a circuit with specialized nodes, but it's very interactive itself. So the hearing brain very much engages what we know, our cognitive, sensory, how we pull together what we hear with what we see and what we smell, how we have sensations of the sound. So we have to integrate the information from our other senses, and the hearing brain is very much, it's right there. So cognitive, sensory, motor, sound is movement. And to create sound, you have to move. And movement is such an enormous part of sound and vibration, and it engages how we move. And I mean, if you just think think of speaking or think of playing a musical instrument, you are listening, while you are resolving the physical complexities of moving your voice or your fingers across a keyboard. You are listening to the sounds, and you are then adjusting your movements based on what you're hearing. So your motor system is deeply involved. Cognitive, sensory, motor, and reward. Sound really influences and then right away engages how we feel. From the very beginning. Oh my God, I'm afraid. Something is vibrating, and I better get out of here. I had a bad experience with that sound. This is a sound I really like. This was important for procreation. This was important for food. And our how we feel about sound is very, very important. And so if you think just in general that our hearing brain engages our cognitive, sensory, motor, and reward system. So it engages what we know, how we feel, how we move, and how we integrate information from our other senses. That is the way the hearing brain works. And our sound mind is taking all of that information together and shaping it by what we're born with, our experience in the past, our experience in the present, that shapes our experience in the future.
I want to break that down a little more again for our audience as well. one of the major things that Nina has done in her lab is she had a breakthrough with how to interpret the studying of the electricity in our brain. It's called frequency following response, FFR. She was using FFR to understand the signal, the pathway flow in the brain. And through using this diagnostic, was able to further break down 4 sound ingredients that happen while the brain is hearing. And using these ingredients was able to even further understand what could go wrong and how we could fix it. And so there are things like FM sweeps, harmonics. These are some of the basic sound ingredients. Nina, can you talk about those a little and why those are important to measure?
So if you think about sound, and if you measure a sound wave, you can, well, again, we live in this visually biased world, and sound is invisible. But with vision, you can see, okay, I have this item here, and it has a shape, a size, a color, a texture. These are ingredients. Sound also has ingredients. Sound is invisible, but it has ingredients that if you think for 1 minute, you realize there's pitch, timing, timbre, loudness, phase, frequency modulation. There are many, many ingredients in sound. And so there are ingredients in the sound wave, and the brain needs to make sense of these ingredients. And one of the metaphors that I like to use is I think of the brain as a mixing board. So think of the faders on the mixing board being tied to each one of the sound ingredients. And based on your life in sound, the languages you speak, the music you make, the noise you live in, these faders are going to be the relative height of these faders are going to be in different places that will reveal what your strengths are and what the bottlenecks are. Mm-hmm. Mm-hmm. And so, and yes, we're deeply, deeply, deeply interested in using this information, to really applying it to how we think about the world and how we engage with it. So for example, we've learned that the musician brain really strengthens the harmonics and certain aspects of timing. That is very much a part of the musician signature. Mm-hmm. We have learned that, interestingly, language. So if you think of harmonics, so the harmonics enable us to distinguish, is it a flute or is it a piano playing the same note? So the pitch is the same, but this note sounds different if it's played by these 2 instruments because the harmonics are different. Well, the harmonics also let us know whether we are saying D or G. It is in the harmonics. That's one of the very important cues. So these harmonics are important ingredients, important cues for music and for language. Mm-hmm. And so if you strengthen your brain's ability to make sense, to make sound to meaning connections, to make sense between these ingredients, the sounds, and various meanings, then you are strengthening your brain not only for music, but for language. And we also know that kids who have certain language impairments have bottlenecks in precisely some of these ingredients, the harmonics, for example, the FM sweep, some aspects of timing. So making music really strengthens the brain for music and for language.
What was really exciting to me about this whole line of research was the ability to study children who are raised in impoverished environments. What we have learned is that there is a specific neural signature in the auditory brains of these children. And so what you are talking about is that by understanding that these auditory brains have both a less precise processing of the sound details that come in, and more static present in the brain, we can begin to understand how to correct that, because what we're basically saying is that you can't receive the signal as clearly, and there's more interference in the brain. So what does come in can't get processed as well. What can we do about that neural signature of poverty in terms of your research?
First of all, that was really well put. Next time you write the book. So yeah, a signature of poverty. We know that that linguistic stimulation is very, very important to the development of the sound mind. And what it's been known for a long time that there is a relationship. It's certainly not a perfect relationship at all, but there is a relationship between maternal education and linguistic stimulation. And so some of the listeners might be familiar with the 30 million word gap, which is the idea that kids whose moms have less education are likely to hear 30 million fewer words than kids whose moms have more education. This is, again, in populations. There are many, 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 many exceptions. But we had projects going on in Chicago public schools and in Los Angeles schools in the gang reduction zones of Los Angeles. And so these were in low income areas. Most of the kids qualified for subsidized lunch. And we just divided those kids in the same classroom, same teacher, based on their mom's education, thinking that that may be an index of maternal stimulation. And what we found is that the kids who likely have had less linguistic stimulation were kids who had a brain that was described very much as you did, where the processing of sound ingredients, if you are linguistically deprived, you have not had as much experience making sound to meaning connections. So the particular ingredients and the way that the brain now makes sense of these important ingredients that are crucial for language, that's diminished. And yes, there is this, internally, the brain creates electricity all the time. And so there is electricity that can be more or less synchronized. And this neural noise is excessive in the kids with linguistic deprivation. And so we were wondering, might this be malleable, and can we demonstrate that? So we had some kids who were, involved in music education, regular music education, and other kids who were involved in other enrichment activities. And what we found is that the kids who were engaged in regular music education, these particular sound ingredients were strengthened, and it partially offset what we called the signature, the neural signature of poverty. We also found that speaking another language, because many of our participants were Spanish speakers, so they spoke Spanish and English, and that wonderful sound to meaning flexibility that they have learned by having two languages also was protective against the poverty neural signature.
I just want to say that this blows me away every time I hear about it or read about it. I myself have done a pilot study in the lab, and I know how incredible it is to be able to replicate anything with any certainty, let alone to be able to take the next step and say, well, we have identified a place that is not working, and we can replicate correcting this pathway every time we do this activity. So I just want to honor all your years of hard work and dedication that have allowed us to come to some of these incredible solutions, which are really non-invasive, accessible, inexpensive. I'm really excited for the world to know about you.
I think
Not,
that's really a very
yeah,
important part, which it's a theme that runs through the book. But the last chapter is very much a call to action
yes.
to really think about, our life and sound matters. So let's think about the choices that we make for ourselves and for our children, the choices we make educationally, the choices we make in medicine for healing. These are things that we have some control over, in our own tiny ways. And also, I have there's a whole chapter on noise. We live in a very noisy place often. And, there are things that we can do. There are also things that we can lobby for. But I think, again, because sound is invisible, we're very cavalier. People don't, again, they don't realize often, we don't realize the important effect that noise, for example, is having on our ability to think, our ability to feel, our ability to move, but really, and all from our ability to hear. Because remember, the sound brain is vast. It includes cognitive, sensory, motor, and reward processes. And there have been studies, many, showing that children, for example, who are educated in classrooms that are overlooking a highway are learning more poorly than kids in the same school whose classroom is overlooking a field.
I do want to mention here for the listeners that are interested in research-based solutions that there are a lot of lists in this book that talk about where the research is and what we can do. Specifically, there's a list on page 167 about music therapy, research-based music therapy solutions. I also want to mention that at the end of her book, there is a whole chapter that is a call to action, and it talks about, it references many of the things that we can do to nurture our sound mind and choices we can make that we may not be aware of right now. We're going to come back to some of those things in a bit, but I wanted to take a minute and ask a few questions about binaural beats. So what are binaural beats? This is a technology that really has come into consciousness in the last 50 years. And I like to think of it as a brain hack. It falls in that category of brain hacks that we're all studying right now. How can we affect the brain into different states of consciousnesses? So binaural beats is a sound brain hack. And it is created by taking a tone and splitting the tone by a certain amount, a specific amount, let's say 8 hertz, and then sending one signal to the left ear, say that signal is 440 hertz, and then sending the other signal to the right ear. Let's say that signal is 448 hertz. So that creates a difference in the tone that your brain is processing. And in the process of regulating that sound difference, we are finding that the evidence shows you can affect states of consciousness in the brain. So the one other thing that I want to say about that is that binaural beats activate a hearing pathway that we already have. Binaural hearing is how we locate sound. If you think of like a bat, echolocation, we have the ability to locate vibrations in space and understand our relationship to them. Is it a tree falling? Do I need to get out of the way? Is it going to eat me? Am I going to mate with it? Like, what is it? We understand a lot of these things through our binaural hearing, which is essentially any sound that is not directly in front of you. If it's just a little bit off center, then we will understand it through this binaural hearing pathway. So I'm a little curious, what is the difference really between the artificial binaural beats that we make in the studio and the natural binaural beats that we hear in nature all the time? Obviously, they don't continue as long and as consistently in nature, so that's one difference. What else is there?
Yes, you can create binaural beats. You can create binaural beats with sounds that are directly in front of you, and you can hear the the uh, the the beat frequency, which is the difference of these two sounds. You can hear it. It is part of how we hear. But you can help it along, and you can also be creating. I mean, as I understand it, and I really don't understand um, a lot of this, but my understanding is that well, we know that there are particular rhythms in the brain, and even in my book I have a whole chapter on rhythms outside the head and rhythms inside the head. So outside the head are the rhythms in the sound waves, and then we have the rhythms in our inside the head, in our brain waves, in our electricity, the currency of the nervous system. And there are some fundamental brain rhythms, very slow ones, that we have known about for a long time, and probably people are familiar with alpha and theta and beta, uh,
Gamma, delta.
gamma. So these are brain waves that are occurring, certainly below 100 hertz. So, they're pretty low frequency, actually. Um, and our brain uh, has these rhythms, and certainly there have been associations with, the alpha rhythms with focus and attention, and the delta rhythms and theta rhythms with more relaxation. And so if you can, I mean, and our hearing brain, I mean, we are interactive creatures, right? And so in the same way as we can entrain with each other when we sing, when we clap, right? When we dance, we can entrain with rhythms all around us. You can entrain your brain to, if you have created sounds that are matching, say, a theta rhythm that you're trying to get your brain to synchronize to, you can, create a a set of sounds that will likely enhance those particular brain rhythms.
So where we are in the field right now is that there is evidence, I'm not going to say proof, but there is evidence that binaural beats do produce these various states of consciousness in our brain. Let's say relaxed or sleepy or focused. Those are the ones that we have the most evidence for. We've also learned that there is not a strong enough frequency following response. There is not a strong enough electrical response in the brain to consider binaural beats to be a form of entrainment. We have a lot of research that shows that sound, that rhythms entrain the brain, but not binaural beats. We don't understand really most of what binaural beats are right now. How do binaural beats actually affect the brain? Well, the primary hypothesis in the field, which I quite like actually, is that some of the data from the binaural beats goes into a secondary auditory pathway called the reticular activating system, or the RAS, which is located in your brainstem. And this neural network is also responsible for our states of consciousness. It's the gateway to our states of consciousness. Again, sleep, or that middle state of slightly awake, slightly asleep, and wakefulness. So the idea is, well, That neural network also takes in all of the sensory information, sight, sound, touch, smell. It's in the thalamus, and it directs us as to how to respond to our environment. And I very much liked your definition of the thalamus as a searchlight for consciousness. So how would you approach this? What kind of questions would the brilliant Nina Kraus brain ask around this topic? How do we even begin to understand what is happening here?
Yeah. Well, I guess, you know, I see um, the hearing brain and the brain in general as both an interactive circuit that affects many areas. And also, there are particular hubs and nodes that we know are important for certain jobs, but they all interact with each other. And so, you know, this is, you might think of it as a paradox, but as with many deep paradoxes, both, you can have two truths. You can have two things that seem to be opposing be true. One is that there is some specialization in the brain in different areas. And the other is that the brain has to, in order to work, it has to work all together. So the special, you can't say that a particular function is happening here. It is both happening here. It's predominantly engaging certain mechanisms that might be happening here, but it's only really happening because it's attached to an entire network of brain and body. So back to the reticular activating system, you know, and first of all, that searchlight metaphor is not mine. I don't remember who came up with it. But the reticular formation is it exists throughout the brainstem and midbrain and thalamus. It's a whole network that modulates our arousal, and it's always there. It's always part of what is going on in our brain. Um, I you know, and so in the different ways that we can engage our arousal, and clearly the reticular formation has a role in how much we're paying attention, how drowsy we're feeling, how asleep we are, um, that and other interacting networks are part of the system. So we are deeply built to remember information that happens through sound. You know, we've learned our ABCs that way. Some people learn their periodic tables with song. Um, so sound is very, very sticky. And our memory for sound, you know, if you think, well, who are we? What are we? We are our memories, and our memories for sound are very strong. And again, they come through years and years and years and years of experience. So, you know, my if one of my sons um, shows up or calls me, you know the expression, it's so good to hear the sound of your voice. Well, why is it so good to hear the sound of his voice for me? Because I have had years and years of sound to meaning, cognitive, sensory, motor, and reward interactions with him with that voice.
That's interesting. That's interesting to me because one of the most successful ways I noticed in the clinical studies that I reviewed, one of the most successful ways that we measured binaural beats was through functional connectivity. And that is essentially a measure of how the various pathways in the brain share electricity. So it's measuring the amount of electricity that goes, say, between the auditory brain and the cognitive center, or the reward center, or the motor center. When is the communication lighting up? That's what functional connectivity is studying. I think you've said something really interesting here, which is, I know you talked about functional connectivity in your book, using that as a way of measuring. But what we really want to think about in the field is, how do we move forward from here? Our diagnostics are not accurate enough. Functional connectivity may be a way forward. There are also ways of applying diagnostic tools to EEG readings, like artificial intelligence is starting to come on the scene and giving us a much more sensitive ability to interpret the EEG readings. Those are both things that I think may come forward to help us further understand what is actually going on here in these very complex systems.
There are many individual differences. So I think that that's always, and I think that that's one of the difficulties with some of these, with any study in science, is that we look at effects that can have some statistical significance in populations of people, but then when you try to apply it to individuals, individuals are not populations. And so it's sometimes difficult to apply what it is that you have learned across a lot of scenarios and a lot of different people. Also, I'm skeptical about I think in some ways, functional connectivity is tremendously important, and imaging, in the brain is very important. But I also think that it has the potential to mislead us, because there's so much going on in the brain besides what you're measuring. And I don't really think that it is a matter of just having higher and higher resolution, because I don't think that love is happening here or fear is happening there. This is an interactive system. So in some ways, by looking for where something is happening, it's kind of back to what I was talking about earlier, this idea of, yes, there are particular areas, but they only make sense to the extent that they work together. And a final thing is that, again, while artificial intelligence and technology have a huge amount to give us, I mean, we're right now using technology to have this conversation. And so there are many things that I am personally grateful for. On the other hand, the idea, and this is such a common metaphor of the brain as computer, is completely wrong-minded in my opinion, because the brain works nothing like a computer. We understand computers, we don't understand the brain. So I think that we have to. I think that it's important to embrace how the fact that the brain is so not understood and complex. It makes it very beautiful. And I think that there's, A of all, I think it's just wrong to make the brain computer analogy, and B of all, I think that there's a lot of hubris involved in thinking that we can manage people.
I agree with a lot of what you said, maybe all of it. The dream is to create a personalized diagnostic One of the conclusions that I came to in my research was that we needed a way that we could be with each individual, right? Because 100%, every sound brain is different, every individual is different. How can we create a tool to help so many individuals? I'm actually working with a group in Europe right now called WeVoice that is doing just that. And it is through software, it is through the smartphone. You can diagnose through biometrics the stress levels of the individual, and the software, the algorithms, allows you to prescribe the right kind of sonic medicine, the right sound medicine or playlist for that moment. That to me is an extraordinary breakthrough.
Yeah, and I don't know that I would say that the primary way of making those connections is in the real world and not through technology, but it is through conversation and through music. And
Fascinating.
you know, I really do think that our basic biological systems are ones that we have to be careful about, because we learn. We will learn, as you know, with a different hearing aid. That will really change your relationship with the world. So it's going to be very important that you have a particular hearing aid, and that you, as a sentient being, really make decisions of, gee, I've been using this for a while, and this is just not working. I'm going to make some changes, or whatever. But it's something that you that you learn and make judgments for yourself. And again, I know that there is a lot of transcranial stimulation that is used, and this is something that is very helpful in certain kinds of disorders. But I mean, I personally, I wouldn't even engage as an experimental subject in a TMS study, because I mean, I know that our neurons operate by electricity and magnetism. That's the currency of the nervous system. You can certainly stimulate a part, you can stimulate your brain, and something might happen that you might like or not. But what else could be going wrong or right?
It's true. We don't have any level of precision yet, and any real scientist will be very clear about that.
That is, I think you said it really perfectly, is that people who are exploring these domains, the really thoughtful people, are doing so, really appreciating what can go right, what can go wrong, and realizing that there's just not going to be an app to fix this problem in everybody.
Nina, one thing I've always been curious about is the music emotion connection. So you tell us that the sound pathways are intimately connected to the reward pathways, and the reward pathways are in the limbic brain, where emotion is also processed. So how can we think about that in a therapeutic sense? How can we work on our emotions through music, through sound? Are we doing that right now?
So certainly we all know that music has an emotional engagement with it, and it can be happy, it can be sad, it can be um, it can produce all kinds of induce all kinds of emotions. Um, I guess similar to my view of clearly the limbic system is involved in emotion, but it is the limbic auditory, the cognitive sensory motor, the fact that the limbic system is part of this whole system that has to do with sound is, I think, the very important piece. And the fact that, if it isn't just music, because we all like different music. We have different memories, we have different associations, we have different relationships to a passage of a few notes that we're trying to learn to sing with the and it's this tremendous feedback of you're singing, you're listening to yourself, you're feeling a certain that and my music teacher tells me, Nina, if it feels good, it sounds good. And I think there's a tremendous wisdom there, as I'm playing whatever instrument. um, there is this constant connection. And so, yes, I do think that there is a lot of um, there's a lot of opportunity for us as a society, for us as individuals, for us as parents and friends to use music for healing.
I have another question. I have a lot of people come to me with questions about misophonia, which is the hatred of sound, specific sounds that make you furious, and tinnitus, which is the ringing in the ears, which actually I have both of those. I've collected quite a few sound issues. And my question about this is, you talk in your book about how those occurrences create negative emotion, and this negative emotional feedback loop starts. How would you suggest that we work on that? How do we break that negative emotional feedback loop? All of your answers so far have been about an organic, system-wide response.
And different. What works for one person is going to not necessarily work for another person, because we have different sound minds based on our biology and what has become of our biology based on our life in sound.
Okay.
So you had mentioned in some correspondence that you found, and many people use white noise as maskers for
Yes.
tinnitus, and also people use it for um, increasingly to try to keep babies from waking up from external noises. And what the biology speaks to me in that um, we know that babies especially are, we're just amazed by how quickly they make sound to meaning connections. So their developing brain is just ready to do that. And we know in experimental animals that if you present just moderate level of white noise to cats, for example, little kittens, that the precision of the mapping of their auditory brain just becomes blunted. So and because there is no meaning in white noise. Now, there's certainly meaning in masking, in that, for example, for an adult, if you're trying to sleep, or if you're trying to, um, um, there are sounds that, if it were me and I needed to use some kind of a masker, it would be maybe music or nature sounds, or something that wasn't meaningless.
Mhm.
So I think that that's important. And again, we all make our own choices. Certainly, if it was my kid, my developing kid, I would want my kid to learn how to soothe himself and to wake up and get himself back to sleep again, and to um, you know, and certainly I would never use white noise. Um, so, but again, that's me, and I think that through the knowledge that we have, and I have, what I call my converging evidence, right? Converging evidence, and my own sound mind and my own scientific gut feeling. I have a perspective, and I try to make choices for myself and my family, and what I think we can do educationally and in medicine. And again, it also depends on the context, like this child and that child.
Mhm. Mhm. Mhm.
And and as I listen to you throughout this interview, I feel that you really embody your work. You are inside your work, and your work is inside of you. When you answer a question, you don't go to one specific thing, you go to the system wide impact.
Right? It's not one thing.
Thank you
I'm
for
paying
that.
attention.
I'm listening to you.
Yeah. No, I think that's exactly right.
Mhm. Mhm.
One example that I loved from your book, and this is going to be from the auditory brain motor brain connection, was the researcher was able to create an interpersonal connection with a baby through the use of rhythm. And the way that they tested this was that if they bounced the baby on their lap in rhythm, in connection, that after that, the baby would be more willing to pick up a toy and hand it to them than the babies that had been bounced off rhythm. Pretty clever experiment, right? And a pretty amazing response. Rhythm creates a bond between humans.
Yeah, but it does. I mean, think of what happens when you dance, when you move, when you have a conversation. The rhythm is tremendously binding, and you know, sound has a lot of rhythm, as it's one of the great components inherently in sound, and it is one of the ways that we can um, think about how sound connects us.
I like the example, and then there'll be one final question. But I just want to talk about the example of your middle son, who you wrote about in the book, that had some issues learning how to read. And you brought in all of your research and understanding of the connection between the hearing brain and reading to help your son learn how to read. And he's gone on to be quite successful, you mentioned in the book. But I thought it would be nice if you mentioned for some of the mothers what it was that you did. There are many mothers that have kids who have difficulty learning how to read that could benefit from this information.
Yeah, you wonder about reading, and people might say, "Oh, my child has trouble reading. What does that have to do with sound?"
Mhm.
Everything,
Yeah. Yeah.
because first you learn to talk. And again, think you evolutionarily, we have been communicating through voice or through sound for hundreds of thousands of years. We've only been communicating in written language for 5,000 years. That's tiny, tiny, tiny part of our history. And so we learned first as babies. We learned, well, we learned already in utero. We make sound to meaning connections, and you learn to make these sound to meaning connections. You learn to talk before you learn to write, and as you eventually learn to write, you combine the sounds and the meanings that you already know with a symbol on the page. And so there's a lot of research, decades of research, in many labs all over the world, showing that there is a deep connection between auditory processing, the processing of sound and reading. And rhythm is one of the components there too. Many children who have difficulty learning to read also have some rhythmic challenges.
That's interesting, and it kind of ties into my final question to you, which is, how do you see the future of sound going, or how would you like to see it go? And by the way, for our listeners, there's a wonderful list on page 107 of the already documented ways that sound is an incredibly powerful healer. Things like dementia or autism or motor issues or stress. And you draw a really powerful connection here between sound and its influence on the way that we think or sense or feel or move, right? Those are the categories that you can think of sound as one of the tools in your toolkit to approach a problem that we might be having. So what would you like to see going forward in those categories?
Yeah, let me just mention too, and again, there is this long history of using sound for healing, and I don't understand why sound and music in particular isn't used in more in mainstream medicine. It is it's getting some purchase, but it's one of these things that people need to learn about and appreciate and even just experience with their own maybe aging parent, like Nancy Gustafson, who is an opera singer, renowned opera singer. Her mom was in an elder care facility and didn't even remember who Nancy was often. And Nancy was visiting her, and one day she started playing the piano and playing some Christmas carols, and her mom just began singing. And during that time when they were singing back and forth, they were communicating with each other. And so this memory for sound is a portal to who we are.
I love that.
This is and Nancy Gustafson founded an organization called Songs by Heart, which is one of many organizations that increasingly are using sound to help with memory, sound for motor, sound. There's and one of the areas that I'm especially interested in is we do work on head injury and concussion. So right now we have an NIH grant that is funding our work with all of our 500 Division One, our Big Ten athletes at Northwestern University. So we measure their brain responses to sound at the beginning and at the end of every season, and we find if someone sustains a concussion, we clearly see that their hearing brain is disrupted. Making sense of sound is one of the hardest jobs we ask our brain to do. If you get hit in the head, it's going to disrupt this process. And it is my view that rhythm and rhythm therapies can be used, and again, this is a way in which computer music medicine can be quite helpful to help and train some of the rhythm skills that athletes are incredibly good at just because of what they do. They're very aware of other people's movements, of the rhythms.
That's a nice way to look at that, as the players all engaging in a set of rhythms.
Absolutely. And also engaging in sound in ways that, historically people have been. If you go to a sports medicine conference, people talk about vision, they talk about balance. They're barely starting to think about hearing. And yet athletes have to be able to hear the sound of their clothing, of their coach. I mean, there's so much engagement with sound. And by the way, part of our work with athletes has shown that elite athletes without a concussion elite athletes have especially quiet brains. So as opposed to the child living with linguistic deprivation, we have the signature of the very healthy athlete who has a very quiet brain, such that they can make clearer, better sense and engagement with their environment. So certainly one of the areas that I would personally like to investigate more thoroughly than we have the resources to do at the moment is rhythm therapies in the children and in the Big Ten athletes that we are looking at who sustained concussions. And just overall, I think a good way to end is just, I think that there is an enormous role, certainly for sound and for sound and engagement. Sound connects us. This is a time when we are divisive. There's a lot of depression, alienation. Sound connects us, so we should use sound to connect us. And I think that certainly music has an enormous role. I mean, every child should have a musical education, and it's not about the people who go on to be professional musicians. Every child, just like every child, should be physically strong and flexible. It's not just about the kids who make varsity. And similarly, in medicine, sound has an enormous place, and I hope that our world will come to be one where sound will be used, and music especially will be used to strengthen the sound mind, whether it's developing or whether it's healing. And we're developing and healing in various stages throughout our whole lives. But sound is such an important way of making our mind sound. And as I said, music is the jackpot. And there are ways that I think as a society we could do a better job to make music certainly be an integral part of education and medicine.
That's a great summary. And as a fellow mother, I really loved, I read in your book, the requirements that you had of your children, which was 1, they had to take their academics seriously. 2, they had to always tell you where they were. And 3, they had to always practice their musical instrument. I loved that. And if they did that, they could have free reign. And as a mother reading your book, my takeaway was really for my child that the activities that were essential in my child's life were to play a musical instrument, and then to play a sport, to have athletic activity. And then if you can manage a second language so that your child is bilingual, that's really the trifecta for creating the highest potential auditory brain that you can in your child, which is not only for childhood, but your research is showing that it creates a longevity of that full potential brain well into our older years. And what does that look like? That looks like a brain that is clear, it's quiet, and it's able to understand the data, the signals that are coming in at its highest potential.
So
To connect.
And I love that you bring that in. I love that you tie it into our current circumstances, because if we ever needed support in connecting and coming together, it would be right now. The current world circumstances requiring a lot of love. I am singing many prayers every day out into the world in the hopes of adding harmony and healing and solutions. So in any case, I do want to say to you, Dr. Nina Kraus, thank you so much for all your work on behalf of all of us, on all the good healing that you put out there. Thank you for speaking with me today. and I learned so very much, and I hope so very many other people will as well. Thank you for doing this interview, and I wish you great luck with your new book and all of your very exciting upcoming experiments in the lab.
Well, likewise, I've learned a lot by talking with you, Elizabeth. You're a very insightful interviewer and person.
Thank you. Thank you. And again, one last time, we will look at this very colorful cover of Sound Mind by Dr. Nina Kraus. Run out and get it. I had 3 people send this book to me. And I had to say, yes, I'm already speaking with her. So yes, go and get a copy for yourselves. You can get it right on brainvolts.northwestern.edu. Thank you again, Nina.